In our lecture, we will discuss physical quantities, that is fundamental and derived in CGS, MKS, FES and System International. Further scientific notation, prefixes and the use of these prefixes. Now we will also discuss the conventions to use the prefixes and units. And also we will discuss some units of length, mass and time. So let's start. In the name of Allah, the most merciful and most gracious. Today we are going to discuss the chapter number first of first year physics, that is measurement. So we know that the first topic in measurement chapter is physical. First we will define that what is physical quantities. Then we will go into the first chapter, that is measurement. So in measurement, the foundation of physics rests upon physical quantities, in terms of which the laws of physics are expressed. So the whole physics are the foundation of physics. The foundation of physics or whole physics is based on quantities, and these quantities must be measured accurately. These quantities must be measured accurately. Now with us, some of the quantities are like speed, length, time, mass, acceleration, work, force and etc. All these are quantities which should be measured accurately, because we will apply physics laws in physics. So physical quantities are often divided into two categories, that are basic and derived. So all the physical quantities of physics, all the quantities are derived into two types. So these are not in books, so let's go out of the book. So there are two types of quantities. The first one is fundamental quantities, or the second one is, the first one is fundamental quantities and the second one is derived quantities. Derived quantities. Now dealing with fundamental quantities. So out of large quantities of physical quantities which exist in nature, there are only few quantities which are independent of all other quantities. So there are few quantities that are what? That are independent on other quantities, which doesn't depend on other quantities. So these quantities are called fundamental quantities, and they don't require the help of any other physical quantities for their definition. Therefore these are called absolute quantities. So fundamental quantities are also called absolute quantities, because these quantities doesn't require or no help of any other physical quantities. So this is the first case or the first type of quantities, which is called fundamental quantities. The next type is derived quantities. So derived quantities are all those quantities that can be derived by suitable multiplication or division of different powers of fundamental quantity. So derived quantities are derived from fundamental. By which way? Either by multiplication or division of different power. Different power mean either length multiplied by length. So here in this case length is multiplied by 3 times, so power is 3. This is for example per volume. So in other case, for example for area, length same quantity is multiplied by 2 times, so the power is 2. So derived quantities are derived from base fundamental quantities from multiplication or division. So if length is defined as fundamental quantity, so if length is if length is defined as fundamental quantity, if length is defined as fundamental quantity, then area and volume are derived from length. So then volume and area are derived from length, and these are called derived quantities. So the volume and area are expressed in terms of length with the power of 3 and with the power of 2. So this was two types of quantities that were fundamental and derived. The next is the system. The system to measure these fundamental and derived quantities. So in books they have given international system of units. So in book they have given international system of units. This is also called SI system international. So before going to system international, there are also other systems, like for example I would like to write its name. There are other systems, like the first one is CGS. So there are many systems. So the first one is, we call it CGS. Or this system is also called Gaussian system. Not important for eta, but for eta important for other entities. So in CGS system they have given C means centimeter, so length is measured in centimeter, where G is gram, that is used for measuring mass, so gram. So in CGS system we use centimeter to measure length, gram to measure mass, and the next is second. So in second is used to measure time. So this was our first system called CGS system. There are also another system that we call it MKS system, where M mean meter, K mean kilogram, and S mean second. So we call it MKS system. So meter is used to measure the length, kilogram is used to measure the mass, and second is used to measure the time. So this was MKS system. We have another system that we call it FVS system. So in this system, this is also called foot, pound, second. F mean foot, P mean pound, S mean second. So in this system, length is measured in foot, pound for mass, and second for time. So different system, 1, 2, 3, different system provide different units to measure the length, mass, and time. So the fourth one system is called system international, that instead of these three quantities, length, mass, time, that provides us the unit for 7 physical quantities, and those 7 physical quantities are length, mass, time, and electric current or I. Next is temperature, amount of substance, and the next is luminous intensity. So the system international provides unit meter per length, and for mass they provide the unit kilogram, and for second, and for time they provide unit of second, and for current they provide units of ampere. The next, for temperature, system international unit is Kelvin. For amount of substance they use the unit mole, and for luminous intensity they use CD, which means candela. So this was system international. Now the SI units are mass, kilogram, second, ampere. Now for derived quantities we will use this unit. For example, if area is made of length multiplied by length. So in SI system, the length is in mass, so meter multiplied by meter is equal to meter square. So meter square is the unit of area. Now for in case of volume, volume is equal to length multiplied by length. So in this case, meter multiplied by meter. So we will get the unit of meter cube. And so this process continue in case of work, power, acceleration, or any other derived quantity. So this was System International. Instead of fundamental or basic units in derived, there is third unit or third quantities, and this quantities is called supplementary units. This is called supplementary units that are neither fundamental or neither derived quantities. So in supplementary quantities and in supplementary units, there are two units which we call it radian and steradian. Radian is used to measure 2D angle. Steradian is used to measure XYZ or 3D angle. So now discuss the radian and steradian. Now to measure angle, we use the unit degree. But the SI units or System International unit provides a unit for instead of degree, they use the unit radian. So radian is that angle which is subtended at the center of the circle. So if this is the circle, so 1 radian is that angle when this distance S is equal to radius of the circle. When S is equal to radius of the circle, then this angle or theta will be equal to 1 radian. So theta is equal to 1 radian. Now we also know that in full circle we have 2 pi radian, or we also know that it is equal to 360 degree. So 1 radian will be equal to 360 divided by 2 pi, and that is equal to 57.3 degree. So bear in mind this equation, that 1 radian is equal to 57.3 degree. Now for steradian is that unit SR, which means steradian. So steradian is the angle subtended at the center of the, instead of circle we use steradian for sphere. Sphere means 3D object, while circle is 2D. So steradian is defined as the solid angle subtended at the center of sphere by an area of its surface equal to the square of the radius of that sphere. So if we have sphere like this is the area of which made angle at center, this like the area of cone. So a cone make an angle at the center theta. So if we draw this thing, we will get is like this. So this is theta and this is area. If this area is equal to, so the solid angle is the center of the sphere by area of its surface equal to the square of the radius. So this is radius. So if this area is equal to square of the radius, then angle will be equal to 1 steradian. Now we know that the surface area of a closed surface is equal to 4 pi r square. So according to the definition of steradian, the solid angle subtended by a closed sphere at center is 4 pi r square divided by r square. So the area of a sphere is equal to 4 pi r square. So to find the steradian is equal to area and divided by r square. So here area is equal to 4 pi r square divided by r square. So r square cancel with r, so we will get 4 pi SR. So in one sphere there are 4 pi steradian, while in circle there are 2 pi radian. So 2 pi radian in one circle, and there are 4 pi steradian in one sphere. So this was all about System International derived quantities, and the next topic is SI prefixes. The next topic is scientific notation. So Writing numbers in power of 10 are standard form like m multiplied by 10 raised to the power p, where p is power and m is the number. So this form is called scientific notation. So what is scientific notation? Writing numbers in power of 10 or in standard form is called scientific notation. The internationally accepted practice is that there must be only one non-zero digit. Like for example 1, 2, 3.4. So in this case, to write this in scientific form, there must be one non-zero digit number. So here is instead of 1 we have 2 digits like 1, 2, 3. Or for example, in this case 0.001234. So we can move this decimal or we can write this into the standard form if we have non-zero digit number. So we will move this decimal to after the right of decimal. So in first case we will move this point to the right of 1. In this case again we will move to the right of 1. So this the number 1. This the number 123.4 should be written in the form of, so we can also write this is 1.234 to the power 10 to the power. Now what will be the value of power? The value of power depends on the movement of decimal. So here the the decimal moved along one number and two numbers, so the power will be 2. The next case here it will be 1.234 multiplied 10 raised to the power. Here will be the power. So the power depends on the movement of decimal. So here it covers one number, then second 0, then 1. So it has covered 3 digits. So the power will be 3. Now if the decimal move towards the left side, so when the decimal move towards the left side, then the power will be positive. Or if the decimal move towards right side, then the power will be negative. So in this case the power moves towards left side, so this is positive, plus 2 or simply 2. In this case as the decimal move toward the right side, so the power will be 1, 2, 3. So the power is minus 3. So this is the point. Now in physics, the next is prefixes of power of 10. The next is prefixes. So in physics we deal from very small, from like micro to very large magnitude. Like the whole physics started from micro level and we goes to macro level. For example, on one side we talk about the atom, while on the another side of we talk about the universe. So the whole physics start from small micro level and goes up to macro level. For example, the mass of an electron is 9.1 multiplied 10 raised to the power minus 30 or 31. So it's I think minus 31 kg. So this is the mass of atom, which is quite very small. While on the other hand the mass of the sun is 2 multiplied 10 raised to the power 30. So on one side we deal with the mass of an atom, while on the other side we deal with the mass of sun. So to repeat this number power 10 to the power 30, 10 to the power 20, we use a special name to this, or instead of this we represent it by letter of ABC. For example, if we have 10 raised to the power minus 18, or we have a number that we call 2 multiplied 10 raised to the power minus 18 meter. So if this is the length, so instead of 10 raised to the power 18, we will call it that we have 2 autometer. So we will call this 10 raised to the power minus 18 auto. So what is prefixes? Prefixes are the special names. These are the special names given to the special power of 10. So we have special powers of 10 and we called it what? We call it prefixes. So what are these special power? So special power started from minus 18, 10 raised to power. The next is minus 15. So remember these, this is just the multiple of 3. So 3 5s are 15, 3 6 are 18, and so on. We will decrease. So 3 4s are 12. Now 3 3s are 9. Now this is 3 2s are 6. So 3 1s are 3. Now coming to 3, we will start the number 1 2 3. So this is 10 raised to power minus 2, 10 raised to power minus 1, 10 raised to power 1, 10 raised to power 2, 10 raised to power 3, and reaching to 3, we will again start the multiple of 3. So after 10 raised to power 3, we will use the term 10 raised to power 6, 10 raised to power 9, 10 raised to power 12, 10 raised to power 15, and 10 raised to power 18. There are also the number that are 10 raised to power minus 21, 10 raised to power minus 24, and so on, but this is out of course. So in this way we can also use for 10 raised to power 21, but that is out of course. So here are special powers of 10 which we given special name, and these are called prefixes. So what are the names of 10 raised to power minus 18? So we call it auto, the next call it femto, the next is auto, femto, pico, nano, auto, femto, pico, nano, micro, milli, centi, dc, deca. So there are dc and deca. So for dc we will use dc, while deca we will use deca. This is from deca. So removing these two we will get deca. So dc, deca. The next is hecto, kilo, mega, giga, tera, peta, exa. So bear in mind that the first words all are small letter except last 5. 1 2 3 4 5. So kilo, mega, giga, tera, peta, exa. Tera or tera. So this is wrong. So we will the last 5 are represented by capital letter while the rest are small letter. So these are special powers of 10 that are given the special prefixes. Now I would like to show you the trick that in which way does these prefixes help us. So for example, let's remove this or clean this. For example, the first case. So if someone tells you, so there is no need, for example in first case, if someone tells you that convert 100 kilometer into meter. So the SI unit is meter. So for all numerical or ETA MCQs or MDCAT MCQs or any other test, we will convert this kilometer into meter. So how to convert this kilometer? The next, if someone tells you that convert 100 meter into kilometer, so how to convert these? So the first trick is just write the number. Now I have to convert this kilometer into meter. So it is just simply meter is present, so we have to remove this kilometer. So instead of kilo I will write its value. So what's value? This is kilo. This is 10 raised to power 3. So I will write instead of kilo, this is 10 raised to power 3. So this is actually scientific notation. So 100 multiplied 10 raised to power 3 meters. So this is scientific notation. Now this 10 raised to power 3 has given special name. We call it kilo. So instead of kilo we can write 10 raised to power 3. So this is meter, or we can also write it as 100, 1, 2, 3. So this is 1 10 100 1000 10,000 1 lakh meter. So this was converting kilometer to meter. The next case, if someone asks that convert this 100 meter into kilometer, so they have given us 100. We don't need to deal with 100. Now they have asked, the meter is given. Now they have asked me to convert into kilometer. So here I need just kilo. So if the best way to get kilo here is we will multiply and divide 100 meter by kilo. So this is just multiplication and division by kilo. Because I need kilometer, so I will multiply and divide it by kilo. So here I get my answer, required answer, that the answer is 100 divided by k kilometer. So this was the required answer. So but in number we can't write kilo, so I need a number. So 100 divided by kilo, where kilo is equal to 10 raised to power 3, or 100 divided by 3, so moving this upward, so 100 multiply 10 raised to power minus 3 meter, kilometer. Or this means that the point has moved towards 3 points to the right side, so taking it opposite, we will call it 0.1 kilometer. So this was the trick. If someone asks you to convert 10 meter into 100 meter into centimeter, so it is simple, converting into meter into centimeter. So we have meter, so to convert it into centimeter we just need centi. So to putting centi in multiplication, we will also divide by centi. Now what is the value of centi? This is centi, 10 raised to power minus 2. So instead of centi I will write 10 raised to power minus 2, or moving it upward we will write it as 10 raised to power 2. So this will convert it into, so this is 100 multiplied 10 raised to power 2, or 100 into 2 centimeter. So this was the conversion trick. If you have any other MCQs, you can ask me in comment or can send us on WhatsApp number. So this was prefixes. Now we have deal with prefixes, scientific notation, already SI system of units. So there are few terms or few points. So I must tell you that. So the first one is that if you want to write the unit of force, so we know that the force of unit is Newton. So there are two Newton, one is scientist and the other is unit, and both have same name, that is Newton. So which one is Newton and which one is scientist? So we can write Newton in two ways, Newton starting from capital letter and Newton. So according to English rule, we say that whenever you want to write a name, the first letter will start from capital. So the capital letter shows us scientist. If you want to write Newton, so this is scientist name. So if you want to write Newton starting with small letter, so this shows us the unit of force. For example, if someone says 5 Newton force, so 5 Newton or 5 Newton. So this one is correct while this one is wrong, because Newton, when we write to start it from capital letter, this shows us the scientist, while if it starts from small letter, then it will show us unit. Same way if 5 Pascal, so 5 Pascal or 5 Pascal. So this is wrong because this shows a scientistness and this is right. The second one is if you want to represent Newton force or any other unit by single letter. So the Newton is represented by N, Pascal is represented by PA, H is represented by Hertz, and we represent meter by M, or velocity meter per second, or kilogram. So see, look, in first here meter I wrote it in small letter. Again in kilogram I write K in small. But in case of Hertz, Pascal and Newton, I wrote it capital letter. Why? Because this is the rule of units conventional, that whenever the unit is given by name of scientist, like Hertz was scientist, Pascal was scientist, Newton was scientist, so this unit will always written as capital letters. Newton we will write it capital, but if there is two words unit like Pascal, we write it by PS, so the first one will be written as capital while the second one will be written as small. So again in case of Hertz, H will be written as capital while Z will be written as small. So this was second. The next is if you want to write 5 kilometers, so 5 kilometer, so you can't write this way, this is wrong. We will write 5 space K space meter, so there will be one space between kilo and meter. The prefix is in units. So must give one space. Write this one space apart. The next is you can't write double, triple or so on prefix. Like you can't write 1 microfarad. So this is wrong. But you can only write 1 microfarad. Now the next is 5 kilometer square. If you want to convert it into square, it means that simple way is 5 multiplied 10 raised to power 3 10 raised to power in kilometer square. So but this is wrong. The best way is that this square is not only upon meter, it is also on prefix kilo. So this is, we can write it is 5. This is actually this palm. So but we ignore the bracket. So we write it in this palm. Now we can write is again is 5 k square meter square, or 5 multiplied 10 raised to power 3 into square meter square. So these were the rules of, these were conventions for using SI units. Now this was just quite easy, but I would like to tell you some other points, some units of length, mass and time that are important for entry test. So there are some units of length which is quite important, or which are used in physics, like Fermi. Fermi is the unit of what? So Fermi is the unit of length. It's quite is equal to its value or 10 raised to 4 minus 15 meter. The next is X-ray unit. So this is also the distance unit. So we write is X-ray unit. So X-ray unit is the unit of 10 raised to 4 minus 13 meter. The next is we have another unit, we call it angstrom. This is also the unit of length, of which is equal to 10 raised to 4 minus 10 meter. We have in it another unit which we call it micron. So micron means micro. So the micro value is used for 10 raised to 4 minus 6. In the last one is light year. So light year is the unit of distance covered by light in 1 year. That's of which value is equal to 9.46 multiplied 10 raised to 4 15 minutes. So these were the units starting from small value and going up to large value. So this were Fermi, X-ray unit, angstrom, micron and light year. Same as in case of mass, there are some units for mass which is quite important, like Chandrasekhar unit. This is called Chandrasekhar unit, or we simply write as CSU. That is equal to 1.4 times of the mass of sun. So Chandrasekhar unit is the large unit that is used for 1.4 times is the mass of sun. So its value is equal to 2.8 multiplied 10 raised to 430. 2.8 multiplied 10 raised to 430 kg is the one Chandrasekhar unit. That is largest unit in mass. The next is metric ton. So 1 metric ton that is equal to 1000 kg. Now per 100 kg we call quintal. 1 quintal is the mass unit that is used for 100 kg. Now atomic mass unit is also the unit of mass, or mass of proton or mass of neutron is the order of 1 AMU. So this is smallest unit, like proton mass is 1 AMU. AMU is also the unit of mass. So this was the unit of length, this was the unit of, these were the unit of mass. Now what in case of time? Unit of time. So normally time is measured in second. We can also measure in hour. Also we can measure it in minutes. So these are the units of time. For measurement of time, we can also use the terms year. So this was the units of length, mass and time. The next topic is dimension.